Hey guys, my name is Esther Martinez, and today I'm going to be discussing finding solutions to a quadratic function using the quadratic formula. Okay, so let's write that down. Our goal. Find solutions to a quadratic function using the quadratic formula. We're just writing the goal down so that when we are studying for a test, we can easily turn back, and instead of scrambling through your lecture notes, you can just look at the goal and you'll know, oh hey, this is the quadratic formula, and you'll know exactly where to go to. Okay. Okay, so before we even attack the quadratic formula, let's recall a couple of things. So, recall. What is a quadratic equation, first of all? So a quadratic equation has highest degree 2. So for example, looking at this function, the highest degree is going to be 2 because the degree is the exponent attached to your x. So for example, this 5x has degree 1 and this x squared has 2. So if the highest exponent that's attached to our x is 2, then we call that a quadratic function. Okay, let's recall another thing. A quadratic function in polynomial form looks like this. F at x is equal to ax squared plus bx plus c, where a, b, and c are going to be real numbers. And a is always attached to the x squared. The b is always attached to the x. And then the c is the number without any x. So it doesn't have x. Going back to our formula over here, we have x squared plus 5x plus 6. Our a, like I said over here, is attached to the x squared. So our a is actually an imaginary 1. Our b is attached to the x, like I said over here, and that's a 5. And then our c is what's chilling out over here. It doesn't have an x in it, so our c is 6. Okay, so it's not too hard. We've seen all this stuff before. We actually call a, b, and c coefficients also. That's just the math jargon that's appropriate. Now, algebraically, when I say solve the quadratic equation, I really mean set my function equal to 0 and solve for x. So, solve the equation means set f at x equal to 0 and solve for x. Previously in our other classes, we saw that we can factor a trinomial like this for example. And we can solve using that. That's the factorization method. So going back to our example, x squared plus 5x plus 6, using whatever factorization method that you learned previously, we know that we can factor it into x plus 2 and x plus 3. So if I said, hey, solve this equation, I set it equal to 0 and solve for x. But factoring it, that's the same thing. It's just looking at our function in a different form, factorization form, and I set that equal to 0, which is a little easier because now I have each individual factor equal to 0, and I could solve those individual equations, and I can get x is -3 and x is -2. Awesome. Now, if all was good in the world, then we would always be working with functions that are factorable. But consider this. So consider x squared plus 7x plus 5. And I'll give you 5 seconds to factor that. Work over here. Okay, so you guys should be done. And your answer should have been, I can't factor that. So let's rewrite that over here. Consider f at x is equal to x squared plus 7x plus 5. Not factorable. Okay, so if we can't factor it, there must be a different method to solve that equation. So that's exactly what brings us to our goal today, and that's the quadratic formula. So, definition. Given a quadratic equation, we can solve using the quadratic formula. We may have seen it before from previous algebra courses, but this is what it is. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. So notice this is a lot easier because this is exactly telling me what my x is going to be. I just plug it in. And where do the a, b's, and c's come from? Well, that's why I introduced the polynomial form from the very beginning. Because the a, b, and c are exactly the a, b, c's from our polynomial form. They're the coefficients. They're the numbers in front of the x squared, the x, and the number without the x. So using this formula with our equation over here, let's example. F at x is equal to x squared plus 5x plus 6. Okay, I told you already that a was 1, b was 5, and c was 6. And we literally just plug it in and solve. So negative b, -5. And when you enter these things, I want you to put in, instead of b, I want you to put in the parentheses and our value of b. Sorry, that's a +5. And for the very reason that when these get negative, we might forget to distribute. So putting parentheses on our input is going to help us visually see when we have to distribute that negative in. So -5 plus or minus the square root of 5 squared minus 4ac all over 2 times a, which is are 1. A and C. A and then C was 6. So I'm literally just plugging in my A, B, and C. It's already given to us. Okay, so now we can just solve this out. And we continue on over here. Looking at what's under the square root sign, we have 25 squared, or 5 squared is 25 minus 4 times 1 times 6, that's 24. All over 2 times 1, which is just 2. Okay, so what's under the square root? It's 1. 25 minus 24 is 1. So we have x is equal to -5 plus or minus the square root of 1 out of 2. Square root of 1 plus or minus 1. So then we have x is equal to -5 plus or minus 1 all over 2. And this plus or minus breaks us up into those two cases that we had to consider earlier when we factored. So x is equal to -5 plus 1 out of 2, and x is equal to -5 minus 1 out of 2. We can solve a little further. X is equal to -5 plus 1, that's going to be -4 divided by 2, we get -2. Over here, -5 minus 1, it's -6. Divided by 2, we get -3. Notice, we get the exact same answers as we did when we factored. So the quadratic formula is pretty cool because it's going to give us our answers. It's just another method. And actually it's a little better because we can use it even when our function isn't factorable. So it's kind of like the go-to method. The only bad thing about it is that it's time consuming, and depending on what numbers we're inputting, then it might get a little hard. In this case, we're just working with 1, 5, and 6, but you can visualize, or you can probably see that if we were working with decimals, squaring a decimal isn't going to be the best thing, but it's still going to give us our answers. Okay, so another reason why I like the quadratic formula is because we're not always guaranteed real solutions. And our quadratic formula is going to tell us. So this is another definition. A discriminant is, and that is going to be b squared minus 4ac. Notice this, the discriminant, is exactly what's under our square root in our quadratic formula. Now, we know that we can't have a negative in the square root because that's an imaginary number. So our discriminant has to be if the discriminant is less than 0, strictly less than. Remember, we can take the square root of 0, but if our discriminant is less than 0, then we can automatically know that the solutions aren't real. And we can stop once we find that out. For example, let's look at f at x is equal to x squared plus 4x plus 5. Okay, we can't factor that. So let's hit it with the quadratic formula. If I said solving using quadratic formula, get x is equal to negative b. What is my negative b? My b here is attached to the x. It's a 4 plus or minus the square root of b squared minus 4ac. My b squared, it's going to be 4 squared minus 4 times a, coefficient from the x squared, which is 1, times c, which is 5, all over 2a. Okay? Well, under our square root, that's going to be 16 minus 20. So negative 4 plus or minus square root of 16 minus 20 all over 2. 16 minus 20, that's a negative number. So we can automatically start, our discriminant is less than 0, it's a negative number. So we know that our solutions aren't real and we're done. Factoring wouldn't tell us that. So again, let's recall what we found out. Given the quadratic formula, or given a quadratic equation, we can solve using the quadratic formula, which is this baby right here. We know that it's going to give us our solutions. It's just another method. We could have factored if possible. If we can't factor, it's our go-to method. What else did we learn? We learned that the discriminant is pretty crucial. The discriminant is what's under our square root sign. That baby can be negative, and if it's negative, we can pretty much stop and we can say, hey, we aren't going to get real solutions. So we learned this term too. So hopefully that clarified a couple of things at quadratic formula.